All right. So, welcome everybody to Arch's DataWorks Maryland meetup. I'm extremely excited to have Steve from Amuda talking about attribute-based access control. I think Steve and I have been talking about doing a meetup for a while now, and we finally were able to make it a reality. So, I'll let him go in a little more detail about himself and his background once we get started. But before I hand it over, I always like to thank our sponsors and just to give a little heads up on some of the upcoming events. So we have three sponsors. They've been with us for a long time now. Baron Technologies is one of our sponsors. They're a small defense contractor company. I recently think that they got acquired and they're part of a larger organization now, but they're still probably doing some very interesting things. So if you're interested in learning more, feel free to reach out to myself or connect to Baron directly. ClearEdge has been a partner and are actually helping also in the conference that I'm putting on, and they do a lot of data science, data analytics, software engineering work for the intelligence community. Very, very great company. If you're interested in learning more, again, reach out to them or I can always make the introduction. Areas Ventures is my company. Honestly, if you want to learn more, just reach out. And I love to set up a conversation. I love meeting other engineers in our industry or in the Maryland area. Upcoming, so I'm working on the next couple months. We do have the April meetup posted, which will be focused on machine learning and AI for disabilities. It's a very interesting topic. There's actually a smart cane. So someone's developed a cane that actually will use AI to help those that are blind to navigate. So instead of them having to have a walking dog or someone else to assist them, the idea is the cane can actually detect items in the way and kind of halt the walker. So we're actually going to have a couple folks that are involved, everyone from people at universities and NVIDIA come and discuss like how AI and machine learning can be used for disabilities. We still do the newsletter every month. Would love to have more people subscribe. We send that out through many channels, but we try to put interesting topics and articles. I'm always looking for speakers. Anyone who has any recommendation or if you want to speak, please reach out. I definitely will try to get you into the schedule. I'm always looking for interesting topics, and don't be afraid if the topic doesn't feel like it's data science. It really just anything related to data, and really the point is to highlight interesting speakers, especially those in the Maryland area. We do have a conference coming up in June, finally making it a reality, June 4th at UMBC. We have basically the entire speaker schedule set. We have everyone from the chief data officer of the city, from the state of Maryland, data influencers, folks that are working in defense companies, folks that are working in startups. So really trying to highlight, again, a lot of the interesting work that's going on in Maryland. So with that, I'm honored to have Steve. Steve is the co-founder and CTO of Amuda. He has a long time history of designing large-scale geotemporal analytics across the U.S. intelligence community, and he's worked on some of the very first Hadoop analytics and frameworks. With that, I'm going to hand it over. If you have questions, I would say please put them in the chat room, either in YouTube or Zoom. I'll gather the questions, and Steve was kind enough to allow us to ask during the presentation. So feel free to ask anything. And then with that, we'll get started. So Steve, I'm going to stop sharing my screen, mute myself, and you share your screen.
Sure. Thanks everyone for joining, and those of you that hopefully listen to this after we present. Yeah, so honored to be here. I'll spend 2 seconds just talking about Amuda here at the beginning and who I am. Then I'm going to dive into the presentation. So we started Amuda about 7 years ago, as mentioned. Prior to that, myself and some of our founding team did a services work for the U.S. intelligence community, a lot of data analytics type work where we kept finding ourselves building the same kind of fine-grained access control over and over again. So we kind of said to ourselves, hey, maybe this is an opportunity to start a company around this. So we started a software company that helps any kind of customer, not just federal customers, to manage access control on their data. So I'm not going to focus this talk on Amuda. This is more a general conversation about why attribute-based access control is important. So I'm going to get going. And as Jason mentioned, feel free to pop questions in there as they come in your head. I'm more than happy to stop, and Jason will feed them over to me. So All right, so I think probably most people watching this will understand what the heck I'm talking about here, but just for those that might not, when you talk about security, that's obvious, right? You want to keep the bad guys out of your network and getting in there and stealing your data. Access control is slightly different. It's when you want to consider the content that you have in your organization and then how you want to protect that content from your own employees. So it doesn't necessarily make sense that every marketing analyst needs to see a social security number. Maybe, maybe not. So these are the kinds of rules that you want to apply to govern access control to your data in a granular way. And this has become more prevalent, or people are thinking about this a lot more. So in the 2000s, it was like, how do we get as much data as possible and store it in a meaningful way, to then lead to the 2010s, where everyone is really focused on how do we derive value from that data. And now we're in this world of responsibly leveraging data. And I think data consumers or people that use, like, for example, cell phones and apps are becoming more aware of what's happening from a perspective of, sorry, my alarm's going off here, of their data being used potentially not as they expected. And so organizations have to think a lot more about how they do this granular control on that data against their own employees, right? So instead of how much data can I get, and certainly you can continue to get as much data as possible, but it's really about, once you have that data, how much information do you really need to do your job at hand? And that's really where access control helps. And it really, a problem creeps in when you start to go down this path. And it's really, at its simplest form, these two things. There's rule complexity, which is going to really limit the amount of data for use, and then user complexity, which makes it really hard to manage what the heck is going on. And there's this industry term I'll talk about a lot today, which is called role explosion. So if you think about rule complexity, this chart in the, I don't even know what this is, fuchsia, this is the data that is actually available for you to use. And these different kinds of rules, kind of think of this as limiting. Like if you had a free for all against all your data, this whole thing would be this fuchsia color, right? But since we have these rules, it's stopping us short. And you might have business rules, regulatory rules, contractual rules, and it's not necessarily the rules that are blocking access. It's the fact that you're kind of having to cut this data up with the dumb analogy I use here is cutting a pizza with a snow shovel instead of a knife. So if you have really coarse grained controls, it leads to less data in the hands of your analysts. So that's part of the problem. And I'm going to use a bunch of dumb analogies through this whole presentation. And I mentioned a second ago, role explosion is the other problem, which really creates what we would think of as a house of cards. So as you start to accumulate more and more roles to deal with all these users and their different types and the rule complexity, you end up with this house of cards where it's really hard to understand the impact of a change before you make it, and you're afraid to make those changes. And it's really hard to understand what's going on at any point in time in terms of who has access to what. So, continuing to beat this horse a little bit, as you think through all the different kind of rules that you need to enforce, you end up with potentially hundreds of thousands of rules. And this is not an exaggeration. We see this in many of our customers that have been historically using an RBAC model, a role-based access control model, to manage access, and it's just completely gone out of control. So how do you actually solve this problem? So these are the three pillars that we focus on with our software product. Today, I'm going to generically talk about this one on the left, which is attribute-based access control, and why we believe this is the right way to scalably manage access to your data at a very granular way too. All right, so we're going to talk about role-based access control, which is RBAC, versus attribute-based access control. And I really think these are poorly named terms, and I'll dive a little bit into the why in a second. But before I get there, so again, another dumb analogy. So a good way to think about RBAC, and this is the best analogy I can come up with because everyone has sent an email at some point, is let's say, I'm working at Amuda and I want to send an email to all engineers in Boston. So we have an office in Boston, right? Is there an email distro for that? I don't know. Maybe there is. I start typing Boston. I don't really see anything. I start typing engineer. I don't really see anything that makes sense. Even if there was something named like eng-Boston, would I be sure that it's really sending the email to the right people? Probably not, right? And so you either take the risky approach of just using the one that looks right and sending the email and hoping it gets to everybody, or you take a conservative approach, which is list out everyone that you think the email should go to one by one in your 2-line and then send it. And this is the same kind of issue that people using role-based access control face. Is there a role that meets what I'm trying to accomplish in terms of access yet? Just like, is there a distro, an email distro? And if not, should I go create a new one, or should I just like manually grant users access? So this is like the dilemma you place people that are managing access control in. If we had, imagine if you had what I call an ABAC emailer, which doesn't exist. I think it would actually be pretty cool if it did, though, if someone wants to start a new startup. But let's say you wanted to email these engineers in Boston again, but instead of having to pick the right email distro, you could instead say, I want this email to go to everyone that has attribute position engineering and attribute location Boston. And then just like that, the email would go to the right place, because in an ABAC world, it's a runtime decision based on the attributes of the user, where with an RBAC world, which we just discussed is like the email distros, you have to pre-compute everything and know all your rules up front and who belongs in which email distro or role, for example, to make that work. So hopefully this clarifies the magic of ABAC. So I'm going to get into more details of like how this actually works with access control and leave this analogy. Well, I guess I'm not. One more slide on this. So at the time of this presentation, we have 221 employees at Amuda, and we have 714 email distros. So we have more than 3 times the amount of emails distros we have employees. And I guarantee if you went and looked at your company, you would have a similar situation. And this is the same situation that happens with role-based access control, because essentially you have to account for every unique combination of access to your data as a role, just like you have to account for every unique combination of emails when you go to send an email. So this is how you end up in this role explosion situation. Okay, so GigaOM was kind enough to do a study on this, and they compared, I don't know if anyone's heard of this tool, Apache Ranger. It's an open source project that helps you do role-based access control, RBAC. And they took 10 policy scenarios, and I would argue they're pretty simple policy scenarios. And these are just 10 scenarios. Like, I want these kinds of people to see this kind of data, 10 of them. And it took 603 roles in Apache Ranger to accomplish this, where it took just 8 rules in Amuda to do the same thing. And again, Amuda is an ABAC system. So this is actually a real customer. They had 96 policies to filter 12 tables using Ranger. And then when they switched to Amuda, that was 1 policy, which obviously saves you a lot of time and money, right? Because it's very obvious what's happening. It's easy to make changes, like I said before, and it's actually future-proof, which I'll talk about in a second. So this is a big difference, and you're probably like, well, Steve, you're full of crap. How does this actually work? So why is this more scalable? So it's because, again, and you kind of grasped this, I'm sure, when I was going through the email example, but ABAC decouples the user metadata from the policy decision. So in an RBAC world, again, we're conflating who the user is with the role and what the role gives them access to. Just like we need an email distro for every possible combination of emails you'd want to send an email to. There's something we term OT RBAC. The OT stands for object tagging RBAC. This makes RBAC slightly better, where it's still roles that drive the policy, but at least through table metadata, you can describe where those policies should apply. So you don't have to apply this policy 1 table at a time. You could say, apply this policy everywhere a table is tagged, this way. And I'll talk a little bit about this later. And then with ABAC, especially if you have OT ABAC, you get a ton of scalability, because now we've decoupled the policy decision from the user metadata, just like I showed you in our ABAC emailer example. And so at query time, we can make a decision. Does this user meet the policy based on their metadata? And if their metadata changes and they rerun the query, it's still going to ask the same question and make a decision. So that's what I mean when I say it future-proofs itself. So what does this actually mean in practice? You end up with thousands of policies and roles with RBAC. You end up with hundreds of policies and roles with OT RBAC because you've at least reduced where they're being applied to this table metadata. But with OT ABAC, because we've decoupled user metadata from policy decision, we've future-proofed ourselves and made this completely minimal, the amount of policies we need, as you saw from that GigaOM study. And by the way, you can go look at that GigaOM study online. It lists all the policy scenarios that they went through. All right, so let me get into some nitty-gritty details here. So this is a good way to think of the anatomy of ABAC. So there's these three concentric circles here where, of course, you want to author policy to make policy decisions. And what feeds that policy authoring is both the table metadata and the user metadata. So you could say things like, I want to mask everywhere there's personally identifying information, which would be your table metadata, for all users except when they are, have attribute human resources. So that's how you pull in that user metadata. And so those three things pulled together is how you get the ABAC policy decisions at runtime. RBAC completely misses this user metadata piece. Again, it conflates everything into the policy's decision via that role. And so by pulling that out into its own circle and capturing this metadata in a single place to help drive policy, you get that scalability of policy management. So this is an actual real example from Amuda, where we are, I'm going to touch on two pieces that we just talked about. So this is the actual ABAC part up here, and this is the object tagging part down here, where it gets applied. So I'm going to start here. So in this case, we're saying, hey, we're going to compare the user's country attributes. Let's just pretend I have US, right? Let's say Jason has Canada, and we're going to compare that to the value in the country column. And if there's a match, so if the country column says US on that particular row, we're going to let me see it. If the country column's value for that particular role says Canada, we're going to let Jason see it. So what this avoids is having to create a role per country. And in fact, it wouldn't even be a role per country. You'd have to do more than that. You'd have to create a role per country combination with RBAC. So like if I could see Canada and US, we'd need a new role that's Canada and US. So with ABAC, this is a single simple policy that future-proofs itself. Because if I get Canada added tomorrow, this policy keeps working. With an RBAC model, that is not the case, right? You'd have to create a role. Basically, you need at least as many roles as you have countries in your data in this scenario, or combinations of countries. And then the OT part is it's going to say, I'm going to apply this policy anywhere I see a column tag country. So this could be potentially hundreds of tables, right? And this policy would get propagated across all of them. So you're reducing complexity down here, and you're reducing a ton of complexity up here. And this is the power of OT ABAC. So, all right, so then I'm going to jump through some more scenarios here. So I want to talk a little bit about Boolean logic and how RBAC says, nah, we don't need Boolean logic, which is crazy. So let's say I only want to provide access to users that have role PII and role human resources to a particular table or column, let's say. So with RBAC, there's no way to do this. Everything is considered an OR. So in order to do any kind of and conditioning, you need to create a new role. And this is just like, I'm going to go back to my email example again over here in the red. This is just like an email. If you put two email distros in your to line, it's going to send it to both distros. There's no way for you to say, I just want the intersection of these two distros to get the email, right? So the same problem exists with RBAC. You need to create another role. So as we saw in that previous example, ABAC, we just needed one policy, and we separated the user metadata from the policy decision. We were looking at the user's country attribute, comparing it to the data attribute, and making a decision at runtime. With RBAC, again, we're going to conflate the access decision with the users in the role, which means you need a role for every country combination, which is what I already talked about. Okay, so then we're going to talk about another problem where RBAC just says, nah, we're not going to support this. So when So at your wedding, and I don't know if anyone really had a security guard at their wedding. Their wedding was a lot fancier than mine, if that's the case. But this is the best I could do with an analogy. You don't create a list of people that are invited and then have a separate list of people that aren't allowed in your wedding, which is basically like the rest of the earth, right? But that's exactly what an RBAC system makes you do. So the reason is you need to consider allow rules and deny rules. So if we're talking about a column masking policy, we would have the users that can see this column are here. And then we have this deny rule where we don't want users to see this column. And this is actually a screenshot from Ranger where you can see this PII users. In this case, it's a group, but same difference. They will see the unmasked value. Sorry, this is probably pretty small, but as you can see, it says retain original value. And then these people that are in this public role, which is the deny role, they are going to see the null version of that column. So the problem is the deny role does, it nullifies the column for the deny role. They're not going to see that column. But the problem is the deny role also needs access to the table, right? So if they have access to the table, we have to remember always to make sure they see null in this column, but also the PII users see the unmasked value. So we have to make two decisions for every role that has access to the table for everywhere we have a policy. So this is not the principle of least privilege access. And so if we go back to our example, I'm going to expand our dumb analogy again a little bit. So access to the wedding is like having access to the data table, right? And then access to a piece of wedding cake is like having access to the column. So with RBAC, they do have least privileged assumption, or you can do that for access to a table where you say, I only want these people to have access to the table. In our case, it was the PII users in the public. It was the PII role and the public role, right? But then once they have access to the table, you need a second and third guard to manage who has access to the wedding cake or not, right? Because it doesn't assume least privilege access. So with ABAC, we can actually assume that. So we can say, I only want people with these attributes to get access to the table. And similarly, I only want these people to get access to the column. So essentially, you build exceptions to rules and it assumes least privilege access. So this is a big deal, right? Because if you screw this up in the RBAC world, then you're going to leak data. Okay, how am I doing on time here? We're a half hour in. So I probably got another 10 minutes left. We'll leave some time for questions, but let's talk a little bit about object tagging. So I promised I'd come back to this. So I'm going to work this chart from bottom to top here. So this is our physical world. Was there a question? Do you want me to pause for a second, Jason?
No, I was saying that if anyone has a question, feel free to post and I'll start gathering them.
Cool. So at the bottom here, we have our physical world, right? These are our databases, our hosts, our tables, our schemas, our columns, our users. A user counts as a physical world thing, right? Of course. And then we can create this semantic world on top. And I'll talk a little bit at the end here on how Amuda does this, but you can tag all your data with its, and maybe semantic isn't the word everyone would use, maybe it's an ontology, whatever you want to call it, but you would tag your data with what it represents, right? Like you might have a table over here that has a column with PII, personally identifiable information in it, and you might have another table over here with a column with PII. You might have a column here with that contains emails. It doesn't matter what these tables or columns are named, because you can actually reference these tags on them as basically their like semantic meaning. Like this user could be tagged with HR, but there could also be a column in here tagged with HR. So if you do this layering approach of the semantic world on top of your physical world, it makes it really easy to build these policies like this. We could say mass columns tag PII for everyone except users with group HR. So again, this single policy hits this PII tag, which gets applied to two columns at once in different tables. And this might be like in your Snowflake database. And over here, this might be in Databricks, right? You don't have to care about what the physical world looks like when you build your policies right like this. And again, it's going to consider user attributes. So it's going to say, hey, what users have HR, they can be excluded from that policy, like we just talked about with the principle of least privilege access. So that's like in a perfect world, how this semantic policy management works in the OT and the OTA back I was talking about. But there are things you need to consider. And this isn't necessarily like an RBAC limitation, but I'll show you why it typically is. So if you look at this, we've got a social security number column and an email address column. Social security number is tagged PII and entity.ssn, and email address is tagged PII and entity.email. So let's say we build two policies. We have policy one that's masked by making null anything tagged PII, and policy two is masked using hashing anything tagged entity email. So what the heck happens with the email address, right? It's tagged PII and it's tagged email. So do we null it or do we hash it? And these are the kinds of conflicts that can occur. So typically, every RBAC tool I've ever seen, it uses policy order to make this decision. So essentially, if policy one is first, it's going to take precedence over policy two. And that may intuitively make sense, but let's go back to what we just talked about. Remember, we're going to have potentially thousands of roles and policies with RBAC. So now if I need to make a change, I need to consider all policies that exist before I can make that change. So I need to go through and say, all right, let me find everywhere that's tagged PII and email. And then let me find any existing policies that's doing something with PII so I can update it to consider email and hash it if I actually want emails hashed. So this is a complete nightmare, right? Whereas with our product, and I think ABAC makes this a lot easier again because you have fewer policies to deal with as well, is you can use a tagging hierarchy. And so we can actually use depth to represent specificity. So in this case, PII is at the root of our tree, but entity.email is one layer down. So we can call this more specific, right? And if it's more specific, then we can assume this takes precedence. And the beauty in this is you don't have to understand the precedence in your policy building. You can represent that precedence in your ontology or taxonomy, whatever the hell you want to call it. And that will, and then that allows you to freely build policy in a vacuum appropriately using this semantic layout, which we think is really powerful. So again, goal in life with all of this is make policy management as scalable as possible. All right, so some other things to think about. Privacy is a continuum. So we talked at the very beginning about how you don't want to cut your pizza with a snow shovel, right? You want to use a knife. And the reason you want to do that is you want to get as much data in the hands of your analysts while also meeting all your regulatory and privacy controls, right? So that's kind of like the tip of this square, right? If I gave everyone just access to all the data with no policies on it, it would be 100% accurate, right? You'd see all the raw data. I mean, minus the fact that you might not have collected everything, right? But at least you're seeing 100% of the data if you're up here. But there's no privacy being enforced. There's no regulatory controls being enforced, right? If you're down here, you're overprotecting, right? You basically have blocked everything and there's no data left to do anything with. So really where you want to end up is somewhere in the middle here where like people are getting full value from the data, but you're also meeting all your regulatory controls. And this can be very hard to do. And I'm going to run through some scenarios why. So this is what I'm covering here are these things called privacy enhancing technologies, or PETs for short. And this helps you, get in this corner up here in certain scenarios. So direct identifiers are things like social security number, account number, phone number, like something that someone would look at and immediately associate it to you, right? They'd be able to find you immediately. And you don't use PETs to protect these. You would just do things like nulling out that column or hashing the values or encrypting it. And this essentially makes that column semi-useless, right? Hash is somewhat useful because you can still group by those values, or you can still order by them or count them, but you just don't know what the real value is. Nullifying a column is going to make it completely useless. So these are things you want to do with direct identifiers. Indirect identifiers are different, and they can still lead to data leaks. So you may have heard of this like Netflix challenge where Netflix got sued, but they released like all their viewership information, and they had some algorithm challenge where I forget exactly what it was. It was something like, can you build an algorithm that can guess the next movie someone would want to watch? And someone took that data and essentially took the ratings from one of the users and was able to indirectly identify that user based on stuff they were posting on some other website. So they basically like linked up the Netflix data with this other website data and were able to out that person. And there was some sensitive stuff in there that she was watching. So she sued Netflix successfully and won. And this is a great example of a linkage attack. So you can take what would not be considered directly identifying, but in combination with other information that the attacker knows, they can, link to that person and break their privacy. And so this technique, k-anonymization, can help with indirect identifiers and allowing you to get utility from this column while at the same time meeting privacy controls. And then sensitive data would be things like search terms I'm using or favorites, or maybe like a disease I have, right? And we can use something called local differential privacy or randomized response to protect these. And I'll talk about what I mean in a second. So again, you want to allow people to get use of this data, but not, get sued, right? Or break someone's privacy. So we want to get more data in the hands of our analysts while still meeting the demands of legal, right? So k-anonymization is a way of making your data more generic, but still useful. So in this case, we have 10 distinct views of these little person drawings, although I struggle to see all those distinct views. And we boil it down or generalize it to 3 distinct views instead. So it's harder to say, hey, I know there's one person in there that's blue, and if I go find them, I can figure out their privacy, their salary, right? In this case, they're like, oh crap, there's 4 people that are blue. I don't know what their salary is, right? So a more concrete example of this is we've got this gender and race column, and I'm going to start with this Shrive person, right? And Shrive is female and Spaniard. So if I knew that there was only one female Spaniard in the data set, I could come in here and find this row, even if I didn't know their email address or name. This is probably a bad example. I probably should have masked these 2. And I could figure out their skills or maybe their salary, right? Just by using that indirect identifier. So what k-anonymization does is suppress these highly unique values so that you can avoid those kinds of linkage attacks. So in this case, we determined that female and Spaniard together was so unique that we had to null both out, whereas just Venezuelan alone was so unique that we just nulled that one out by itself, but left male there. So you can still see we're getting a ton of use out of these 2 columns, but we're not opening this up to any kind of privacy leaks. And then differential privacy is similar. Rather than suppressing values, we fuzz values, if you will, or add noise. So in this case, we're looking at average salary for female and male, and then we add some noise to that salary so it's not exact. So these are aggregates, and this is really good for aggregates. And in fact, we expose the noise level to the user, so they can actually, like through math and statistics, figure out the true value without the noise. But if they queried a single user's row, they wouldn't see their true salary. So this is pretty powerful to allow you to do aggregate statistics without actually breaking anyone's privacy. All right, so I'm going to spend the last few minutes just talking about how this works in Amuda, since I went through all this. So you would actually register your data with us. And by register, I mean, essentially we just pull in metadata. We don't actually copy your data. We just you say, here's my database tables. Amuda, go take a peek at my schemas. And then we'll like do a little sampling and we'll guess at what's in those columns. So we can say, hey, this looks like a person name. This looks like gender, for example, and we'll tag it. And that's that semantic layer that we build. And then you can create and manage policies across that layer, again, using our ABAC model in a very scalable way. And then we push those policies down into the native database and enforce them invisibly. So an end user running queries doesn't know any different that Amuda is there actually enforcing the policies. And so this is, I pulled out 2 examples. We have many of these, but this is just Snowflake and Databricks, for example. We'll actually administer policies in Snowflake and join that user metadata at runtime in that policy to enforce the policy when they're querying the table. And similarly in Databricks, we have a Spark plugin that does a similar logic where it looks at the user metadata and at runtime makes that decision by rewriting the Spark plan and enforcing the policy. So, and then of course we have user-defined functions that could do those pets that I talked about earlier. So Amuda is not in the data path at all. The users are still querying Databricks and Snowflake like they always have. And the policies are based on this centralized metadata about the users and data, which we've been talking about. That's like the magic of ABAC. And these policies can be enforced consistently across all these different database vendors, where we can get you the row level, column level, ABAC, the pets. We do some auditing as well, I didn't talk about. And then the data discovery and classification, which gives you that semantic layer. So you get all this out of the box so that you can build these policies in a very scalable way in whatever data platform you're using. And this is just a real example from one of our pharmaceutical customers that's using several of these data warehouses and is able to manage all these policies from a single place using Amuda on top of them. All right, so we are at 42 minutes. I wanted to spend a little time mentioning that we are hiring. So it'd be awesome if anyone's interested. We're in the Maryland area. We're in fact right on top of University of Maryland, essentially. So this is the entrance to campus right here, and Amuta's back here underneath this new hotel they built. So we've got a nice space right there. I think the Capital One Innovation Lab's like right over here. So we're right next to campus. We bring in a lot of interns and hire interns from the University of Maryland as well. And these are some of the positions we have open. We also, of course, support a hybrid type environment where people can work from home some days and come in the office. So anyway, I encourage you to go look at some of our open positions because we desperately need more engineers, and this is fun stuff to work on. I hope this was interesting. I mean, just the way we bake in that ABAC model into those databases and work on those pets. It's exciting stuff that I think can energize folks. So anyway, I will stop there. That was my last slide. I can open it up to questions here.
So there was a couple questions, and I had a couple questions. So back to your product, one of the questions was like, so how do people set up the attributes that are used? Is that something where they enter then your tool, or can they use like existing attributes that are already there?
Yeah, that's a great question. So you can typically use existing attributes that are already there. And the nice thing about our product is that we can suck those attributes in from anywhere. So typically the basic way is whatever you're using for identity manager, like LDAP or Okta or Active Directory, whatever that is, we would pull in your groups and attributes from there. And then we could also reach into other systems you might have. Like if you've got like a training course system that keeps track of all the training everyone's taken, we can pull that metadata in and you can use that to drive policy. And then you could augment all that by adding attributes in Amuda if you'd like as well. So there's several different ways you can skin that cat.
So that kind of leads into the next question about what the skills and experience are needed for people that are like utilizing your tool. And then actually, and I just want to add on to that, because you mentioned about pulling like the training information from another system. So is that something where you have like software engineers that would be utilizing and writing like the glue that brings it together? Or is that something that Amuda kind of handles itself?
Yeah, so the first part is in a basic integration where you're not hitting a bunch of external attribute systems. It's literally as easy as this. Like you come in here and build the rules, just like I'm showing. This is a screenshot from our UI where you're like picking drop downs. You hit go and it deploys the policy. So anyone can build a policy. And the nice thing about it, anyone can read a policy and understand what the heck's going on. You don't need to be a software engineer to do that. Now, that being said, typically data platform teams are the teams that buy us, and they want to manage policy through data ops workflows that they already have established. So you can do things like represent these policies as declarative files and source control them, and you can push that state to Amuda. And we have a full API set to manage all this. So that's like, if you don't want to screw around in our UI, you can do it that way. To your follow-on question, yes, you do have to basically implement an interface that we expose in order to pull in attributes from other systems. But the identity managers, that all comes out of the box, like hooking into things like Okta and AD and all that.
So I was just curious, like who's generally responsible for these policies? Is that like, is there a set role in companies where they handle that?
Yeah, that's a great question. So we see the full spectrum there. A lot of times it is the legal or compliance folks will write a memo that says, these are the policies that we need enforced. And then the data platform team is then challenged to then meet those standards. And they're like, okay, how the heck are we supposed to do this? And that's usually when they bring us in. So it's usually the data platform team building the rules and then proving to legal and compliance they did it right, which our tool obviously helps them do, both through being able to understand how the policies are being enforced, but also the auditing and reporting, which I didn't really talk about much. Sometimes there are dedicated people whose sole purpose in life is making sure all the data is governed correctly, and they sometimes are engineers, or at least have some level of engineering talent. So that also occurs. But I would argue it's more so the former than the latter.
I'm going to ask this question, Stephen. I don't mean to put you on the spot, but I was curious about, are there competitors to Amuda? And then, a lot of the folks in our community, of course, are going to gravitate towards open source solutions. And I was just kind of curious, like, what is the state outside of Amuda? Like, are there roll your own solutions? Like, are people hacking together ABAC solutions through other means?
Well, so I mentioned Apache Ranger, right? And I talked a lot about that. There's a few products that basically commercialized Apache Ranger, Privacy being one of them. So that's a competitor, but frankly, like when we start to get into competition with them, it's the customer immediately realizes the value of ABAC over RBAC. So I do not know of any ABAC systems that that have been homegrown as I described in this. Now, of course, in our community here, there's also Accumulo, right? But I would argue Accumulo is RBAC as well, right? Because you basically describe the access level that matches up with the, I forget what the three columns are on the in it, but
visibility, right? Is visibility.
Yeah, the visibility thing. Yeah. So essentially, like you represent what the user is allowed to see with their visibility role, and then it uses that to grab the appropriate rows in the database. So I would argue Accumulo is an RBAC system as well.
I'm looking at the Apache Ranger. It looks like it's focused more on like the Apache Hadoop ecosystem. You guys are more focused on like the data warehouses and stuff, right? Or
that's correct. Yeah, the cloud data warehouses. So I showed that in the chart here. We're missing a couple in this chart, but yeah, the stuff probably you folks have heard of, like Redshift, Databricks, Snowflake, Presto, Starburst is a commercial version of Presto, Synapse, BigQuery. So these are the cloud databases, and I don't know if they call themselves databases. They probably call themselves data platforms, but yeah, that's where we focus. We have a SaaS offering as well. You can also deploy Amuda on premise. So we do have some public sector customers that are running Presto internally, for example, that use Amuda.
So with the privacy enhancing technology stuff, I was kind of trying to follow that. Are you saying that you use like the attributes to determine when to mask or when to nullify things? Is that kind of where you're going with that?
Yep. Yeah. So these are just, at the end of the day, these are just masking types, just like nulling and hashing. It's just fancier masking types. But so the ABAC would determine if you get the k-anonymized version of the data or not. And honestly, the attribute could drive, like for differential privacy, the attribute could drive how much fuzz we add to the data or noise. So there's all kinds of tricks you could do there with the user attributes.
Cool. I guess if anyone has any other questions, I'm going to ask my last question, but feel free to type. You had mentioned that you were hiring, so I guess can you go over some of the skills, like the tech stack that you guys are using? I was kind of curious.
Yeah.
Java, Elastic. I'm not quite sure how you guys are building the system.
Yeah, so we've got a lot of JavaScript in our in kind of our main services, and then it kind of a lot of SQL in those database integrations, some Scala development for our Spark stuff. But honestly, we do not hire for specific skill sets. We hire for aptitude. I want very curious people. Some like I think other folks would appreciate our values in our company too. We're very low ego type company where no question is a dumb question. And so I love to just hire curious folks that are good at their jobs, regardless of what their background is. So I think if what you saw today excited you and you're of the engineering mindset, like I would more than happy have you apply for a job and talk to us, even if your skills don't align to what I just said tech stack wise.
Cool. And I guess because I know there were some people in the audience that were kind of looking at ABAC solutions. I guess they could just reach out to you if they wanted to get a little more information.
Oh yeah, so I should have put this on here. So let me I'll write my email right here. So it's just great. Never mind. Let me move it up one. It's steve@amuda.com. So yeah, more than happy to respond if you just want to hit me up directly, either about a position or about our solution. You can also, like if for example, you're using something like Snowflake, they have something called Snowflake Partner Connect. You can spin up our SaaS instance right from there and start playing with it without even talking to a human if you want. So there's lots of different options for learning more about our product, but I'm more than happy to just have you shoot me an email.
I actually did have one more question I forgot to ask. So are there any shortcomings to using an attribute-based access control?
Yeah, so I think you were kind of getting at this with your attribute question, but there's a little bit of like upfront design work that you need to do. So it's kind of like there's this like curve of effort in the beginning, but then like you have this this slope that just goes down, and like you never have more work after that like beginning effort. Where with RBAC, it's the inverse. It's like it's easy at first, but then like you're painting yourself into a corner basically because the slope of work that you have to deal with just keeps growing and growing and growing. You get that role explosion problem. So I think that's like the downfall or not downfall, but the one negative is you do have to put like a little bit of design effort up front.
I guess you could run in the case though that you get access to a new attribute that you want to include into the decision making process, and you would have to go back through, I guess, and change your policies, right? Like if you got a new data source.
Yeah, kind of. So that I didn't actually dive into that. I don't know why my camera's so fuzzy right now, but I didn't really get into this, but it is possible to also support attribute hierarchies. So, we can do like tricks where you could say, hey, if this is a sub component of something else, like they should still have access. So there's ways. Again, one of the goals is to make it very scalable, and I think a big piece of that is future proofing your policies, so you don't have to think about them. Both don't have to think about them based on like new attributes, but also don't have to think about conflicts. So our goal is anyone should be able to build a policy and it would appropriately merge with other existing policies. So that's like another big design goal of ours.
That makes sense. Cool. Well, I don't see any other questions. Thank you, Steve. I think that was very interesting. I think it's definitely an area that I wasn't as familiar with, and we've had some other presentations related to privacy and access control, but not on this topic. It looks like you've built a really cool product, and it's interesting to hear you say that there's really not a lot of competition, because it does seem like a complicated thing, and definitely an area where people are probably just catching up on. So thank you everyone for attending. If you're interested in learning more, please reach out to Steve directly. He's very responsive. I can attest to that. And I hope to see everybody at the next meetup next month on the Smart Canes. And then if you guys can join us, I'd love to see everyone at the conference. And with that, I'm going to end the meeting. So thanks again, Steve.
Yeah, thank you. Appreciate everyone joining.
All right. Goodbye, everybody.